So, hello everyone. So, we are starting this second workshop on the digital twins of the ocean. First, you have heard about the initiatives that are currently ongoing on this topic. You heard about Tito, you heard about Mercator Ocean, you heard about the European policy for this area. Now we will tell you how we can contribute to the digital twin of digital twins. So how we are making things in ILIAD, and we will start by Pedro starting to tell us about the requirements for the digital twin. Thank you.
Thank you, Artur. So, hello, I'm Pedro Sarmento. I'm from the WAVEC. We are responsible for the work package 1 of ILIAD that I will present. And I'm here to present to ILIAD. So, ILIAD. What is ILIAD? I think you already heard about ILIAD today, but I'm going to give you a deep dive on what we are intend to do and how we are thinking of doing it. So first, ILIAD. What is ILIAD? It means Integrated Digital Framework for Comprehensive Maritime Data and Information Services. A very long name, but the idea here is to deliver information and knowledge about the ocean. This is a EU Green Deal funded project. ILIAD is to take advantage of 2 decades of investments in policies and infrastructure in the European Union. And what we want to do is to fuse a large volume of data, dispersed data, semantically rich and data agnostic approach to enable simultaneous communication between real-world systems and models. This is our goal. Of course, one major point of ILIAD is interoperability, because we know that there are a lot of different data sources, and we don't want to create one holistic, siloed system that has all the information. We want to cooperate and capitalize on the information that exists, the information that will exist, because we are not thinking of ILIAD for today, we are thinking about for the future, and we want to make sure that this information is, and we can use, that is spread across different systems, different data spaces. Another point that we want to show as marketplace is a really interesting point for us. We want to make sure that ILIAD can be used and capitalized by third party, not only us, but especially citizen or industry communities. The last part is we want to tackle problems, current and future societal challenges, either from policymakers, citizens, or the industry. This is one of the hottest topics for us. What is ILIAD Digital Twin? So, for us, what we want to deliver is an interactive framework based on digital technologies compatible with Destination Earth. Here already in the previous section were presented all the ecosystem. Destination Earth is one of them, and we want to make this as capable of including ocean simulators on high-resolution numerical ocean models that give toolboxes, digital analysis toolboxes for the users to create what-if scenarios. As presented earlier, one of the major interesting points in the European community and international community is give to the policymakers the capability of simulate what-if scenarios and create the policies that can allow to better evolve and constrain the regulations to the future. Again, we want to focus on the interoperability. We know that ILIAD will live in a complex ecosystems of systems and data spaces. We don't want to create our own, we want to integrate, to add value, and to reuse all other digital twins, either European or global. And we are going to do this on a system of systems architecture. Again, we don't want to create a siloed system with a huge data lake. We want to create something that is cost effective. This is one of the other points important to ILIAD. And I think this slide gives you, especially because of the previous workshop, we understand the ecosystem where we are. We understand that there are a lot of initiatives on the digital twins of the ocean space, and we want to make sure that we cooperate with them and we work together. We understand the mission that was confined to us in the project, and we understand the European commitments that underline the project. And because of this, we are already in conversations with other active projects to make sure that we are aligned. On ILIAD, we also believe, and I think what differentiated us is we are, and we want to be very end-user centric. We created our approach of the project based on what users want. And for this, we created an architecture. We have created an architecture because we are defining data analytics, artificial intelligence, high processing computing, processing pipeline. This is a very complex architecture, but this is aligned for the digital twins. And for this, we have created an approach to the project. We have multiple work packages, where I am on the work package 1, that is the co-design of the digital twins of the oceans. Here is where the teams gather requirements in a co-design methodology and define the architecture to meet those requirements. Then we have the work package 2, that is the data acquisition and collection of existing databases. We focus on the sensors deployment, on the sensors input data, and the integration with other systems. Again, a special focus on the interoperability. We don't want to collect all the information, we want to reuse and integrate with other systems, with other digital twins. Work package 3 is the citizen engagement. Here we want to create a community of users around the ILIAD project. This is key for us. Work package 4, so after the work package 2, the work package 4 handles the interoperability issues. We want to have an European interoperability data space. We want to be heterogeneous, and we know that we will increase on the data sets and services available. So we want, and on this work package, we want to contribute to the European ocean data space. Work package 5 is where we have the data analytics. On this, we focus on the implementation of the modeling and the analytics layers for the data services. Then work package 6 with the data visualization is where the user experience, the user interface design, dashboarding, and immersive visualization is defined, and all the user experience is created. And then the work package 7 with the demonstration of impacts of the ILIAD's pilots, where we want to make sure that the end user is engaged. We want to demonstrate the values of our products and services, and we want to assess the effectiveness of the digital twin of the oceans and the sustainability of the ocean ecosystem. So to do this, we have created, To do this, we have divided the ocean in 12 fields. We have, on these 12 fields, we have created 18 teams that are working in defining 18 digital twins. Again, we are not creating one digital twin, as I think it's been said several times here in the previous workshop. It's not one digital twins, it's several digital twins. Digital twins to resolve a problem, to address an issue. I can give you an examples, but I'm not going to cross all the 18, otherwise we wouldn't have the time. But maybe we can focus on the Met Ocean one, because on our perspective this can be a base for the other different digital twins. We can focus on the aquaculture, where we want to create the digital twin for the cages, for the aquaculture production cages, and then create the fisheries pollutions. And then, on top of all these digital twins, and to finalize, we have the insurance field, where we can create the digital twins, that we have a new insurance models that will allow the insurance companies to support the activities and of the industries on top of the oceans. This is my presentation. Thank you. Do you want questions?
Thank you very much. Any question for Pedro? I mean, if not, I pass the word to Georgios. Georgios will be talking to us about sensors, but also about details on the pilots that use them.
Which button is it for to change? This is the button?
Yes.
Sure.
No, this goes back, this goes forward.
So hello, I'm Giorgos Sileos from Demokritos University of Thrace. I'm going to speak to you about key ingredients and examples on the successful implementation of digital twins in the framework of ILIAD. So, as you know, digital twins are the basis in Industry 4 and the revolution of the digital world. And as you know, digital twin, from the previous session, we have defined that the digital twin is a digital representation of the physical state, of a physical system and its components. So you see here that we have an oil platform which is affected by the environment and the oceanographic conditions, but it also affects the environment and it operates on a daily basis. And then we have the digital counterpart, and in order to create a digital counterpart going from the physical to the digital space, you need to have sensors, we need to run models to gather big data, store them in a cloud, and perform analysis with AI algorithms and machine learning tools. Now, in order to, if we develop this digital twin, then we have to go back and to make a connection with the physical space in order to optimize the operations, run a series of controls and tests, and diagnose any problems in the operation of the systems, and be able to reach informed decisions. And this is the essence of ILIAD, really, because we will use all these cloud infrastructures, the data structure, the data sources, the hypercomputers to develop these digital twins that Pedro introduced you earlier, and I will give you some examples, in order to create a series of applications for the various user groups. So these are the pilots that I will speak about. As you see, the offshore wind energy farms, the tidal energy farms, the harbor safety, onshore wave energy, fishery, aquaculture, and mucilage, and oil spills as some examples that we will see today. And starting from a sort of initial classification of the digital twin case study, we can say that we can identify what we call one-way digital twins, which are a representation of the physical space to the digital world, but as you can see, we use sensors, we use models, we use big data, the cloud storage, the machine learning and the AI algorithms, but we are not able to go back to optimize the operations. And this is because in these digital twins we have, for example, the marine litter case, or the pollution of the ocean, or the case of the jellyfish blooms, or the case of the oil spills, or the ballast water, or the metocean conditions. These are digital twins which are considered more marine environmental or ecological digital twins, so we are not able really to control the evolution of the phenomena and the processes that we are digitizing. So in this particular case, I will speak a bit about the oil spill digital twin that we will develop in ILIAD. As you can see in the center of the slide, we have in a previous project called TEC4SEA, being able to standardize a process in which we have downscaled and coupled a series of models like the hydrodynamic model, the wave model, the biogeochemical model, and from there we are able to run thematic models like the oil spill model. But how do we know when the model needs to be run? How do we know when we have an oil spill? So for this, we in ILIAD start to work on an event identification pack, which will give us an opportunity really to know in a near real-time mode the occurrence of an oil spill. So we scan satellite images based on a series of algorithms that identify the spectral signature. We also scan the social media posts in order to see if there are any oil spill references in a specific area that we work in, and then we use Citizen Science app for oil spill records. And all this is formulate the event identification pack that can then be able to trigger the Marinomica package. And from there we are able to alarm and aid the authorities about and seek for the response, and use again the sensors, the citizen science apps and the social media posts in order to evaluate the operations. So for us this is a full circle of an oil spill digital twin. In a similar manner, we can also work with a mucilage. Mucilage is the SIS node, is the occurrence of eutrophication events. We had a series of events recently in the Sea of Marmara in Turkey. And as you can see, again, we have developed a series of algorithms in order to scan the remote sensing images for spectral images, the spectral indices calculation. And from there, using machine learning classification, we will be able to identify the presence of mucilages in the sea. And from scanning the Twitter posts through this algorithm, we are able really to identify the presence and the occurrence of such events in order to trigger again the models, and from there to be able to run what-if scenarios based on which we will be able really to inform the authorities about the probabilities of such events. The Metocean Extreme Events Digital Twin again starts with a conventional prognostic numerical models, and then it utilizes also data from existing resources, from satellite, from sensor networks, databases, large-scale models that are fed to a series of AI algorithms for data that are being fused. We use data analytics, data-driven models, machine learning and pattern recognition, and event detection tools in order to operationalize and alarm and aid the authorities about the response. And you see over there the coastal digital twin that we have developed. In terms of two-way digital twins, we can say that now in this particular digital twins we can go back to the system and control and operationalize and optimize the system and run diagnostics and produce informed decisions. So you see the wave energy, the offshore wind energy digital twin, the fishery and the harbor safety. These are more engineering, industrial, maritime digital twins that we would like to focus on. And you see here the case of a wave energy converter, which is located in Gibraltar. And this is a single point absorber system. We will run a series of models to produce and simulate the offshore winds, from there the offshore waves. We will transform the waves as they approach the near shore zone, and from there we will deploy a series of sensors and we'll run dedicated wave energy conversion models to analyze the behavior behavior of the floater, and then we will go at the end of the system to understand the electricity production, to forecast the electricity production, how much of the electricity will be stored and how much will be taken to the grid. And of course, all this exercise is done to optimize the layout of the wave farm, to operationalize the decision making, to prevent the mechanical damage from extreme wind and wave conditions, the corrosion alert, and to run operational prognostics and to improve the assessment of sighting of such systems in the ocean. In a similar manner, we have also the fisheries digital twin. This is the case of a digital twin that we run in the North Sea, and we have a series of sensors deployed in fishery vessels. And like the towing sensors, the fuel consumption, the landings, and the GPS, and we are able to synchronize the data and push them to the cloud. And from there, we will be able to assess the catch probability, the fuel efficiency, and run more effectively ecosystem models. This is the work which is done by ILVO in Belgium, and it's about the fishery twin in the North Sea. In a similar way of thinking, we have the harbor safety digital twin, where we have, again, a series of boats which are equipped with sensors like GPS, meteorological sensors, echo sounders, and sensors on pitch and roll of the boat. And we will complement the sensors with benthic systems, and we will run sediment transport model. And this is done in order to be able to make predictions about the waterway bathymetric changes, the sedimentation rates in harbors, the dredging recommendations, and to improve overall the harbor safety of the system. So I think that I gave you a good example of the digital twins that we run in ILIAD, just to give you an understanding of the main ingredients and novelties that we will have in ILIAD. We will deploy a series of sensors like gliders, drones, microplastic sensor, drifters, echo sounders, LiDAR systems, low-cost sensors, and we will run a series of models, coupled, downscale, hydrodynamic models, wave, biogeochemical, ecosystem, oil spill, and models from GFT to CFT. And all these resources from the satellites as well will be fed to the AI algorithms for a series of data manipulation, together with the citizen science data from a series of social networks and the semantics. This will be fed to the platform, which is a federated platform. This is mostly the ILIAD platform that will act as a data collector, a simulator, but also as a control room for the various digital twins. And from there, we will be able to give the users a dashboard, a dedicated, customized tool that will be able to see in geo-visualization mode the user experience, a visual user VR. Thank you very much.
Thank you, Giorgio. Any questions for Georgios? Yeah. Thank you. So, can we now? So now we move on to the third presentation on the batch, which is my own, if there is no more questions. And so my name is Artur Rocha, I'm at Inesc TEC, and now I switch hat from the Master of Ceremonies of this session to my own presentation. What do I aim to tell you? To give you a bit of this closeness of how we implement modeling and decision support in ILIAD. So you have heard that we have a collection of models used for several pilots and an array of sensor data across the areas that interest us. So first I will tell you a bit. Oh, sorry. Yeah. So first I will tell you a bit about how we organize the architecture for for this bit of decision support, now instantiate on a small detail of the overall picture presented by Pedro. Then on the next steps on how we implement this. So I'm not going into detail into this. This is not too technological, but anyway, we need models will exist in several places, in several computing infrastructures, and they are registered in a registry. So it's a place to find them, to discover them, no matter where they are. Then, of course, we need to assemble and incorporate these models. And for that, we thought of a sort of a pipeline builder, followed by an orchestrator to implement the several steps in this pipeline. Of course, then the data, the forecasts will go in the designated data spaces we used for our applications. So we first start, and this is the current point in ILIAD from this perspective. We first start by implementing a catalog of models. So these are not, I mean, you can find models everywhere. You can find open source models. These are not naive models. Someone has worked these models and made them fit for the purpose that we need. And now we can find them. We know their resolution. We know which areas they cover and what they can give us. So we can find this through this catalog service. And then, of course, I mean, many things can go wrong. I mean, interoperability, as Alan mentioned before, is a difficult word to say, but even more difficult to implement. But we must do it. So we are creating a set of harmonization services which will handle semantic interoperability, but also other kinds like upscaling, downscaling of models to make them fit together for what we need. Then to implement what we call the so-called hybrid models, what do we do? Basically, we take data, and this data can come from the models that we just found, that are fit to give us forecasts about a certain process. Then, together with sensor data, I mean, with satellite data, with whatever we need to train our model. So previously, I mean, it can be anything, but previously I was thinking more about numerical models. Now I'm thinking more about machine learning models. This is, of course, an example, but this is the mindset for this pipeline. So we use this data, the forecasts, the sensor data to train the models, and then, of course, we need to validate them in situ, to deploy them, and from that, I mean, as previously mentioned, it wouldn't be a digital twin if it didn't close the loop. So we'll monitor and refine. So this is also a very simplistic example on how we plan on to support decisions. Maybe decisions are somewhat simple, so maybe we just need to monitor a stream of data. Maybe we need to monitor 10. Maybe it's a more complex scenario, and we need to do the so-called what-if scenarios as well. In any case, what is depicted there is a complex event processing system, which we will use to, I mean, it can be extract tendencies, it can be determine extreme events, it can be anything. But at the end of this pipeline, this decision pipeline, we will have events, we will have notifications that will help whoever is in charge of this site, of taking decisions. And so in this last slide I put some highlights of this process. So first, discover models using a catalog service. Then, of course, adopt the best practices and community standards to harmonize and to interoperate with the models. Leverage on AI, on machine learning, to have enhanced predictions and through them empower decisions using adequate tools that will turn out into, let's call it, apps to help decision support. Then, again, close the loop, monitor and refine. Thank you. So I don't know if you have questions about this. Thank you. So now, because we need to make the digital twin or the digital twins available to everyone, we need a place where you can go and find them. So I pass the word to Bente, which will explain you the concept of the market.
Thank you very much, Arthur. Yes, it's all fine and dandy to create all this, but of course we want everybody to use it. And what do we mean by a marketplace? This way, maybe? Yeah. So the marketplace, you have seen, is one of the pillars of ILIAD. And as for the rest of the components of ILIAD, the marketplace also needs to be made interoperable, just to make that clear. We are creating twins. This was underlined in the previous workshop as well. And you have already heard about some of the twins we are making, and you will learn how you can make your own also. Just hold on. So, the perspectives on ILIAD Marketplace. We have multiple twins. Martin talked about that in Ditto. We have already talked substantially about that. We also have several layers, and I think Pedro showed the many layers that goes into to creating twins, and we need to address that. And it spans over many different scales. We go all the way to global, from global to very local, and to very sector-specific twins. So all that needs to be included in the marketplace. Is it, where am I going to? Next, okay. So what is a marketplace? Just to put your right mindset. You know it already, right? A bazaar is a type of a marketplace where you have many vendors selling approximately the same thing. We have fruit and vegetable markets that are every now and then popping up, maybe on a fixed day. We have shopping malls with a selection of many different types of stores. And we have also online marketplaces like the Amazon that started, by the way, with only selling books, but now sells a whole lot of other stuff as well. And we have hybrid warehouses where we have both a physical store and also they are also represented online. I want to talk now about a restaurant concept. And you see here a picture actually taken from a restaurant here in Portugal, in Lisbon, where you see a different material and different fish that goes into creating dishes. And you can find local fish, local material. You can find also material, for instance, from Norway. The bacalao, the cod come from Norway. And you have maybe some prefabricated food ingredients, etc. So you find a whole range of merchandise in a restaurant. Now, you can present this as a menu, so you can pick and choose for people so they don't have to decide so much. It's easy, I want that menu, or you can have a la carte and pick individual pieces, or choices, dishes. Now, this is somewhat similar to what we want to do in the ILIAD marketplace. We want to offer all the different components that goes into the digital twin. And you see below, I don't know if there's a pointer here or... Yes? You see here the different steps. You collect the data, you manage the data, make them interoperable, you create models, and then eventually you show them on a dashboard, a visualization, applications and services. So all of that goes into our components of a digital twin. Now, very simply, we have products and we have services, but we also have an innovation booster. And that goes on top of the restaurant, because sometimes you are so inspired by the restaurant, you want to make your own restaurant. And we help you in ILIAD, in the marketplace. We actually will offer you services and products and support to create that. We also, and this is important, we also want to extend this possibility to use the marketplace to externals, so third parties. Say, we have been using a subset of EMODnet data in the pilot, DTO, and then, but you want more, so EMODnet will be able to be visible on our marketplace, keep their autonomy and branding, but be available for those who are visiting the marketplace. And this goes for as many as you want. Also outside Europe, as Martin was saying, the ocean is one, and we are not only European, we are global. So, and there are many different users and stakeholders. And we have will develop targeted displays. You know, we will brag about our products and display them the most attractive way that is possible to address specific stakeholders. And that includes actually also the non-experts among us, the citizens. So citizen science and the citizens are actually one of the key stakeholders that we want to help in ILIAD. And we are creating, you see here, a small lighthouse. You have heard about lighthouses today. Zoe from the European Commission, she mentioned that, and also Alain. And we are sort of creating baby lighthouses. And so those who are creating lighthouses in the regional seabeds will actually be able to use the ILIAD marketplace to help them. And I will say a little bit more about the Innovation Booster, as I said. That will actually help you create your own twin. And we have some services. We have an academy. You need to be trained to be able to use this. You have to train among the different capacities, the competence. An expert is not expert in everything, so they need to train to be able to speak to each other. And we also have a business innovation facility, because when you create something, it doesn't stay alive without some support, and you need to follow the whole value chain until you have something that is operational and useful. And that requires actually some expertise and help, and we have that included in ILIAD. We have a policy impact. You heard about all the policies throughout this workshop, right? There are so many. If you want to create a pilot, a digital twin, you have to relate to multiple policies, legislations, and it can be very, very complex. And I will show you something. I will spare that to the last, that we have accidentally discovered so far in ILIAD. We have a blue growth hub. That means there's a lot of people with resources, money or otherwise, that are interested in supporting this kind of projects. So we will facilitate those who are investment funds and bankers, different types of resources. We will help them find the right project or twin for them. And the other way around, if you are created as a scientist, you're normally not that involved in finding funding, but we will help them also reach out to this community. And the marketplace is, of course, a part of the Innovation Booster. Now, the last. Since we have analyzed the stakeholders, we are multiple stakeholders, you saw that. And in order to be able to talk about them in the same way, in an interoperable way, we have done a stakeholder taxonomy. We have built this on other projects and also have done an analysis on ourselves. And the result of that is actually already a policy finder tool, if you like, ILIAD policy tool. That will be made available for the community, the wider digital twin community. And you need to, sometimes you need to actually manage the governance of all these policies, and we also have made a tool for that. Well, it's a prototype, it's very early, I will not go into detail, but it's just an illustration that what can happen when you collect many different types of areas of expertise from many different countries. ILIAD, by the way, is representing 3 continents. It's Europe, it's North Africa, it's also the Middle East. So we are already covering 3 of the continents. And you can imagine that this tool is something that we need when we are operating in the global environment. So here you have a map. You see fisheries, you have harbor safety and in different places, as Sir Giorgio showed you. And so you can look in this area, what are the policies that you need to relate to? And you get help by this. It's unreadable. That's not the point. The point here is that you can identify policies and legislation, etc. in this way. And not working again. Yeah, oops. Going back. Yeah. Okay. So you see here how we are using this stakeholder taxonomy that we worked on together, that is continuously being developed because when interacting with the community, you will discover continuously new things, and you get then a tool to manage all this. Okay, that was it from me. Please contact me if you need to talk about collaboration.
Thank you, Bente. Any questions for Bente or for anyone at all? You can come here. You can ask here.
So for thank you very much for all the presentators, and so for I think is it
Yes, we're here.
okay. So my in fact is not a real question, however, is just a kind of, for example, we are in Algiers, which is a pilot site. We are more managers. So we are working with some methodologies on value chain. And there is many things that are coinciding with your approach, because as you said before, so we have many levels, many layers of for example, the pilot site, the end users, fishermen, but we have other high level of policies, ministers, etc. So now we are little bit selling ILIAD in Morocco, which is not that easy, because we need to update to people that because as you we are little bit in Algiers how to say accustomed or to this from Odysseus. Right now we are carrying many skills. However, it's still complicated. When we are talking last week, we were talking about the digital twinning, which means that we have two oceans, one physical one and numeric one, which is complicated too. So this is why we will have more precise things to discuss to unify the approach, because you said we have another layer which is regional, but we have the local and national aspect. So in this we will talk about in future.
Thank you, Sin. So this is a testimony from one of ILIAD's pilots, and this is an example on how we can use, for example, decision tools and the ILIAD marketplace. So thank you very much, and if you need to anything, just send me an email, send us a contact in any way.